That button didn't get hit. Hello, hey there, it's me, John Park, and this is John Park's Workshop. Sorry about that. Also, sorry about, I don't think Facebook is streaming today. I had everything set up, and then a browser window closed, and when it returned, it got mad. So we are everywhere else that we usually are, but I don't think Facebook is picking this up, sadly. Sorry for anyone who was hoping to watch it there. But look, we're right here in YouTube for sure, because I see we've got our chat happening over there. Dave Odessa, hello. Dave Etchels, Beatagraf Abdelhagen, hello. Randall Bone, hello, hello, hello. Thanks for stopping by. The other chat, so if you're somewhere and you're wondering where to go to chat with people, and if you want to ask me questions or let me know things, then you could do worse than heading to our Discord. Go to adafruit.it/Discord, and then you will look for the live broadcast chat channel. It's that one right there. Got a whole bunch of channels. That's where it's happening during a live stream. So hello to C. Grover, howdy. John Nodge, hey. Paul Cutler, hello. Thin Man, hi. Mouse, hey. Yanisku7, hi there. Starman, hello. David WA90NY, hello. Hi, Brooke. Thanks for the wave. Hey, thanks everyone for popping by. What is this? What's going on? Well, I'll let you know. We've got a few things, a few standard things that happen during this show. So first of all, I will have a coupon code for you to save some money in the Adafruit store. I will have a recap of my Tuesday show, the product pick of the week. I've got a CircuitPython Parsec for you. I've got a little project status update, and also we're going to try to do an ill-advised live on-air update of my Fruit Jam with the absolute newest, latest CircuitPython that Scott had made some changes to that may fix an audio issue that I was seeing. So I'm going to give that a shot. Yeah, Lars.io fixes. You can see right there. This is, by the way, I should say, this is Lars.io Paint Music. So it's my little miniaturized version of the Mario Paint Music program from the SNES cartridge. There's a multimeter beeping at me. And what is there to know about it? It's not Lars.io, which sounds like a CircuitPython library, which now I kind of wish it were. Like simple I/O, that sort of thing. It is not. But Lars.io Paint, Lars.io like Mario. So those are the things that we're going to do. And as promised, first of all, we've got a coupon code. So your coupon code today, it's a little hard to see because it is what it says. It's translucent, semi-translucent. Should be able to see me through there. Translucent. Translucent, translucent. That is your coupon code today, and that is going to get you 10% off in the Adafruit store. you can head on over to that place right there. That's the Adafruit shop. If you head over there, you will see we've got new products, we've got old products, we've got in-between products. If you click on Products, New Products, View All up at the top, you can see what's new, including a bunch of translucent stuff or transparent stuff. We've got these snap-on enclosures, we've got some different USB power delivery cables, and we've got these two new ones that just popped up yesterday, a couple of different power analyzers for USB-C power, monitoring that, a little tiny one and a nice bigger one with a graphing display. Any of those things, you could throw them in your cart. You could get 10% off just by using that coupon code right there. There's a little area when you're checking out to type that in. That does not work on gift certificates, subscriptions, or software, but it works on bits, things, or rather atoms, physical stuff that we can put in an envelope or box and send to you. And it's worth mentioning, if you want to get a bunch of stuff at once, maybe help with shipping, stack up a bunch of things, wait till the time is right. I don't blame you. And what you can do to find out what incentives we've got is go to adafruit.com/free. And we got 3 little incentives there. If you spend $99 or more, you'll get a free PCB coaster with the Adafruit logo on it. If you spend $149 or more, you'll get the coaster as well as a free KB2040, which actually I'll be using in my little demo today for CircuitPython Parsec. And if you spend $200, or I should say $199 or more, you'll get free continental US ground shipping via UPS, as well as the KB2040 and the coaster. So those are some little incentives to get more, to gang up stuff in your order. Either way, you will get 10% off by using that coupon code right there today, translucent, and that is good until midnight East Coast time, United States East Coast time tonight. We've got a GIF I have to check out. Whoa, we've also got a bat logo. What's happening? Oh, this is the live broadcast bat channel. Shenanigans. That's what's up over there in the Discord. So go check that out. All right, next up, I will mention I've got my Tuesday show, which is the product pick of the week show. On it, I like to pick something, sometimes something new. This is a fairly new one here from this week, and do a little demo. Here is a recap for you. It is the TLV320 DAC 3100. It is an I2S digital amplifier for headphones in particular, stereo headphones, as well as a little mono speaker output there. So this is digital audio coming off your microcontroller, Feather RP2040 plugged in, power ground, I2C and I2S all going to those bottom pins on the TLV320. And then I have a set of headphones plugged in, which I am miking using a little amplifier mic there. And then I have a little push button to play a sample sound. TLV320 DAC 3100 I2S headphone and speaker amplifier and breakout? Sure. And I should also mention, if you're joining us for the first time, when I do that Tuesday show, there's usually a huge discount on the product pick. It was 50% off on the product pick this week. So if you can, tune in live. That's when we've got that discount. Okay, next up, let's go to a CircuitPython Parsec. CircuitPython Parsec. All right, let's see. Are we set up for this? I think we are. For the CircuitPython Parsec today, I want to show you how to create a scroll wheel using a seesaw encoder. So we've got this little seesaw chip embedded in the little PCB on this encoder. We have that on a few different little boards, little breakout boards, which mean you can plug them in over I2C, particularly convenient to do it with a Stemma QT cable. And this board will take care of some of the processing. so that your microcontroller doesn't have to. It'll just get I2C messages. In this case, it is a rotary encoder. So we've got an encoder on here, but we're just using I2C. I'm not using GPIO pins on here. And I am setting this up to act as a HID mouse wheel. So what you can see, let's do a demo. I think that'll be easier to see if I scroll it like an actual mouse wheel. If I go and wiggle that knob right there, let me do it so you can see the indicator on it. You can see I am scrolling my code window there that the CircuitPython code is in. It's a little bit self-referential there, I guess. And the way this is working is that I set up Seesaw, first of all. So you can see from Adafruit Seesaw, import Seesaw and rotary I/O. This means we're going to be able to use that library on the Seesaw chip that's built right onto here. The next thing I do is import USB HID as well as the Adafruit HID, stands for Human Interface Device, consumer control, which is the mouse stuff in this case. So I'm also bringing in HID mouse, and I'm able to do mouse wheel to change the mouse position of a scroll in a window. You can also use HID for other stuff like keyboard stuff is pretty common. But in this case, we're using consumer control, mouse. I set up I2C on board stemma I2C, so that's that little port right there. And then I'm setting up the Seesaw, which this one is on I2C address 36. I think you can change that on this one by changing a little address jumper if you want to use multiples of these. And then I'm setting up encoder as rotary I/O incremental encoder. So normally we'd use rotary I/O with a couple of GPIO pins. In this case, we're setting it up with Seesaw. And then I'm also creating a little state variable called last position, which is whatever the encoder position is when we start this up. We remember that so that we can check for changes in the main loop of the program. So now if we check out the main loop here, current position is the encoder.position. So that's a variable to say what each loop of the program, where is this encoder? And the position change is whatever the current position is minus whatever the last position is. So we can tell that differential. Then we check and see if the current position is different from the last position. That means we've changed something. Then we're going to do one of these two things. We're going to either see that the number has gotten bigger or that the number has gotten smaller. Inside of these, either the if or else loop, we then, for essentially every little notch in the change, if we're 1 away, if we're 5 away, we're going to send that mouse message. So if you move it really quickly, we're going to send 5 mouse wheel messages in one direction. If it's greater than 0, then we're going to send it in the positive direction. And if it is less than 0, we're going to send it in the negative direction. This actually turns out to be a scroll up when we go to the right and a scroll down when we go to the left. And then we record that last position so that we have a new reference point the next time we run through the loop there. And so that is how you can set up a mouse scroll wheel using a Seesaw rotary encoder inside of CircuitPython. And that's CircuitPython Parsec. CircuitPython question from the chat or statement. Yeah, Mouse says, wait, so that device was scrolling its own source code? Mind blown. Yeah, it is kind of weird. If I give focus to that window there, we are looking at the code that is, I should have mentioned before, that's running on this little KB2040. So CircuitPython on the KB2040, and the Seesaw board is handling the GPIO of the rotary encoder. This one, by the way, if you're not familiar with these, it actually also, I'm not using this in this code, but it also has a click button, so you could do mouse click with that, you could do other things with that. We also have a NeoPixel on here, so we can use the Seesaw library to send NeoPixel control to that RGB LED there if you want to see that in action. Those are all built right onto the board there. Okay, let's see. Oh, hey, here's this is a nice update question from Dave Odessa over in the YouTube chat. How's the water level detector on your coffee machine doing? It's doing great. You can, in fact, I left the thing public, so if you go to the Learn Guide, I guess I can go there now. I think I have the Adafruit I/O link to my coffee page. If it's not, let me just pull it up here and you can see how it's working, because I use it every day. It works great. Let's go to Adafruit.io. And let me show you this page here. So this is Adafruit.io. If I go to dashboards, espresso machine, excuse me, you can see I'm at about 40% water level. This is the water level changing over time there. And this is the battery level, so I have it at 57% right now. And yeah, I think I got, I want to say something like 6 weeks, it was more, before I had to charge it. I can't remember exactly. I don't know if I'm recording any data that far back on here. But it is, yeah, let's see, is this battery level? So it looks like I charged it on March 31st, I charged it. And so now here we are at the, yeah, in a month we've gone down about, what, half? Less than half. So I think I'm getting 2.5 months out of it. It's not a super fresh battery. I think if I went to a fresher battery, we get more. If I went to a bigger battery. So anyway, it's been great. I love it. It means that I never have to move all the cups and open it just to find out that I don't need to refill it. And when it gets low enough, I refill it. I also have, I think I mentioned this or showed this, I have a, what are they called? On the iOS, there are little actions you can do in these little macro-y shortcuts, if anyone remembers what those are. I have one of those. When my alarm goes off in the morning to wake up, it does a quick ping of this and tells me what the water level is. So that's one of the, it's really the first piece of information I find out in the morning is what the water level is. So thanks for the question, Dave. It is great. It is one of the most useful things and most used things I've probably ever built as an Adafruit learning guide. I use it every day, so it's very helpful. All right. Let's see. Question from Lux. Do I need drivers for the DB9 breakout box? It gets recognized but doesn't seem to want to work. Which breakout box are you talking about? Which DB9 breakout is that? Is that just the DB9 to generalized microcontroller one? I use that like on a joystick. Let us know more. Ask more. Okay, we'll come back to that. In the meantime, let's do a little project update. I just want to go to double check if this is... Okay, it's not published yet. Okay, so I'll do a recap of the guide next week, but I did, if you were on Show and Tell, if you saw Show and Tell last night, I did show off kind of the final form of the computer space arcade miniature cabinet here. So we've got that nice big graphical OLED in there. I have a little mask in there to give that a nice 4:3 ratio. I've got my Feather M4 and a little breakout there for wiring. I also have a battery in there, which normally I'll just have this plugged in. It doesn't need to be portable, but just to show it off right now, it's nice to have that portable. So there I've got my little attract loop of the computer space, sort of an emulation of computer space, which was on TTL logic, so it's not, you can't really emulate software in there, but it's a sort of simulation of it, just as an attract loop, not playable, and I'm just using a little vinyl sticker there that I printed to give the control panel. So that's the state of that. You can also see back here I've got a few iterations of the case, the enclosure for it, or the cabinet for it, but that's my final one there. And all those files are up there for you to print if you want to make one. You don't even have to put a screen and all that in there. If you just want to look at that beautiful swoopy design, that'll be available for you to use as well. And that is going to wrap that project up. I may make some to give out as gifts too to some arcade enthusiasts, but that is, see, Grover says, smells a little gamey. That is the status of that. So, yeah, we can move on from that. That is computer space. I'll go over the Learn Guide a little bit next week. In the Learn Guide, I've got some nice links to an FPGA someone built of this cabinet, which is incredible. I'm not using that because I just wanted to use a small Arduino program on a Feather. There is a reconstruction of the game that someone wrote for the PDP-1, which is kind of neat because Computer Space was actually a riff on Space War, which was on the PDP-1. So there's a really nice web page explaining that code. I was able to use some of that code to feed into Claude to come up with the Arduino for this one. There's also a browser playable version of it that you can check out there too. So those are all going to be links that you'll see in the guide just on the first page of that. John Nodge says these arcades kind of look like the handsets Pro Telephone installers use. I have one back here, don't I? Yeah. You're absolutely right. There's something reminiscent to a lineman's butt set. You tell me which came first, the lineman's butt set or the Computer Space? Valid question. I'm going to hang that right there. This is a rotary one, by the way. I think I've shown this on the show before. Oh, sorry. I'm yanking on my microphone there. That probably sounds bad. Okay, so more on that to come once the Learn Guide is published. In the meantime, let's get back into Larzio music, Larzio Paint music. So let me jump to that view there. I'll put a little screen in the corner. So this is, as a refresh, if you've forgotten, it's been a couple weeks. So this is an RP2350 Fruit Jam, which is something, I'm actually going to also make a version of this for the Metro RP2350 with a couple breakouts, because that's really all this is. This is a sort of neatly integrated version of something that we can do currently with breakouts. So the DVI breakout is how we'll get video over here to the monitor. The TVL 320 DAC 3100 is how we're getting audio out to either headphones or line out. In this case, I'm going to just a couple little USB-powered speakers. The mouse is integrated, although right now I think we're using a hub on the Metro 2350. This has a hub integrated, and there are some timing issues with slow USB 2 devices like this mouse. So right now I think I'll be adding a hub to that. So it'll have a lot of breakouts, but it'll be something that you could build right now once I put the guide out that does not require this Fruit Jam, which is not yet released. And so I've got USB-C for power right now, and in a minute we'll plug that into the computer to update this thing. This is running a cut of CircuitPython that's a few days old that has some of the fixes that Scott put in for some other unrelated USB issues, as well as garbage collection was happening in a way that was causing a lot of timing glitches. So that's good. However, something that was happening as a result of that by accident was audio was cutting out. So we would hear sound for a little while and then it would cut out. What I'm going to do is see if we can replicate that, get that to happen. So let me play some. Oh, I'm not hearing. Okay, we may already have audio cut out. This should be making sound. Yeah. Okay. No sound at all. My speakers are on. They're plugged in. I tested this before. We'll go ahead and stop this, and let me give it a little restart and see if we can get audio working again. And then see if we can get it to work with the latest version of CircuitPython. There's a version out that's Scott said should be able to fix this audio dropout. Okay, so here's. Okay, so there's a little sample of Lars. Let's put some drums in there. Oop. we'll just loop this and play it, and at some point, the audio is probably going to drop out. And we can add while it's playing. I'll keep noodling with it until it does drop audio. All right, well, now it's deciding to never break on me. Let me stop the loop here, just do a couple other things to try to stress it out. I'll loop it again. I'm going to up the tempo. Also erase everything. There. Oh, no. I thought I heard the little sound it makes when it drops audio. Okay, now it's being very well behaved, which is too bad. But I'll just let you trust me on this. Generally speaking, after just a minute or so, it has been having some error come up where it stops playing audio. And I've also noticed some people in the forums asking about this on, I think, CircuitPython using this DAC, and I'm not sure what other hardware, I think a 2350. So what I'm going to do is we'll go ahead and power this off, and we'll unplug pretty much everything from it, and I'm going to go update to the latest CircuitPython. Just kind of, you can see that process. If you are used to just grabbing the release version, this might be interesting to you, and then we'll get to see if it still works, if it breaks things. Who knows? So let me first of all show you where I'm going to get this from, and then I'll set up a little window so that you can see what I'm doing to update the board. So let's go to, easiest way is go to circuitpython.org, downloads, and I'll go to Fruit Jam, which I still don't know why these two cute boards show up. They must have the word fruit in the descriptions or something, but those boards always show up in the search along with the Fruit Jam. So I'll go to Fruit Jam. Now, normally you'll grab this UF2 if you want the release version. That's the sort of stable release, 9.2.7. You can also grab an alpha, what we're considering kind of the release alpha, but that one's a little bit old compared to this absolute newest. So if we scroll down here, you'll see we've got absolute newest, browse S3. So S3 is the Amazon S3 cloud storage server that we're using here. And this is the S3 bin Adafruit Fruit Jam. And then I'm going to look for the language that I want to use. So in this case, I'm going to do English US. Excuse me. And now if you look at the top here at the dates, we've got one from the 30th. So that's like 2 days ago. I'm going to grab that just by clicking on this UF2 link. So that just put that in my downloads folder. And then I'm going to open up a new screen share, and I think I'll just show you a chunk of the screen. That'll be easier than trying to set up a whole bunch of windows. So let me add that right now. How about do it like this? Screen capture, new screen capture. We'll do monitor configure, select screen region. So I'll just pick a chunk of my screen here and then put a couple windows there so you can see. There we go. And I'm going to make another, see that? Yeah. I'm going to make another Finder window. And now what I'm going to do is plug in the Fruit Jam, turn it on, and I should see a CircuitPy drive get mounted. So this one right here, CircuitPy. And what I want to do now is put it into bootloader mode. So let me back out a level here so it doesn't close that window. So on the, let me show you a down shooter view. For a second. Whoop. So on the Fruit Jam here, I'm going to press the first button. We've got 3 buttons here. This one is both a user button while CircuitPython is running, but it's also the bootloader button. So I'm going to press bootloader and then reset over here, release and release. And we should see an RP2350 drive show up. So that's the bootloader drive. And now I will go back to that view. Now I'll go to my downloads folder. And right up here at the top, we see this is this Fruit Jam PR 10299-8F6117 UF2. So I'll drag that onto the RP2350 drive. It's going to copy over. You can see a little copy window. So it's 1.7 megabytes. It'll take a 20-30 seconds or so to copy that over, and then the board should restart in CircuitPython. And I forgot to show you the bootout.txt, which would tell me the version running on there, but we'll take a look at the new one here. So if we double-click in the CircuitPy drive and look at this bootout.txt, this tells me that we're running that cut. That's that same 10.0.0 alpha 2 43 G8 F6177 EB6. So that is the latest release from S3. So that's what's running on here now. So I can eject that, and let's go back over to the bench. Make this a little bigger for a second here. So now I can take that right there over to the workbench. We'll plug that back in. And we are doing this together for the first time. I don't know what happens if this is gonna make it happy. I think Scott has been testing with the Larzio Paint music program, so he's probably done this. I'm probably not the first human to run this. Okay, so now I'll go ahead and turn on the Fruit Jam. Give it a second. Andy Calloway asked, what are we doing today? Upgrading Lars? I'm sort of, yeah. I'm upgrading Larzio Paint music. So this is it right here, and now this isn't a great demo because you didn't see it fail on me before, but let's see if it continues to not fail. That'll satisfy me because that was the issue we were having. So let's see. And what was happening before was that the audio would just cut out as it dealt with some of the garbage collection stuff. So what I'm looking for is mouse worked right away. No restart needed there. It's making sound, and then when I play it, does it actually keep time? Because what had been happening before Scott fixed some of this garbage collection stuff is that the timekeeping was rough. It was also making a lot of audio noises. That was actually the first bug that got fixed, is there were just like random noises coming up on audio. That got fixed, and then that introduced a new problem with the playback speed being really variable. It just couldn't keep tempo. That got fixed, but we saw audio start to drop out entirely, and now this is the iteration where hopefully all those things are fixed. So far so good. Let's drop the tempo a bunch. And let's kick it way back up. I don't remember what I set as the upper limit. Was it 320? Let's see how fast it goes. 280. It's definitely keeping time a lot better than it was. That's great. It's probably not perfect, but we're asking a lot of this. Drop it down to around 100 again, or 140, let's say. I'll stop. I'll play. I'll blow away all the notes. But this is great. This seems to play well, and I'm encouraged to maybe go add a couple other features I wanted to add, like a song save mode, just the ability to hit a button and save, maybe just 2 save slots or something. I don't want to add menu systems and things like that. Yeah, all right. Let's turn off loop for a second. Yeah, Scott had said actually since you always have, when you boot this, you have to go and add some notes to hear if it's working. He was like, yeah, I was thinking of having it just auto populate some notes, but then I realized that's not stressing any of the sprite drawing, mouse moving stuff. So this is good to do these real world tests, but I get it too. It's annoying to always have to lay something in there to see if it's working. So that's why I say it might be nice to have maybe one song that just comes with, and maybe make a little side file, JSON or something like that, or config file that has songs in like a little MIDI notation that we can grab in there. All right, well, sorry I didn't have it break before I had it work, but I'm very glad to see it's working without dropping audio, and the other glitches and things are gone now too. So I'd say this is in good shape. I will go ahead and maybe add that one song mode feature, port it over to the Metro RP2350 with breakouts, and then we'll get this out for you so you can play around with it and see what you think. Andy Calloway says, getting an 80s game vibe, for sure. Yeah, I'm glad. That's the goal. This was based on a, 1992 or so release, the Super Mario Paint for Super Nintendo Entertainment System. So it's definitely late 80s, early 90s kind of sound. All right, I think that's going to do it. So before we go, let me know if you got any questions or thoughts. Charles says, like your shirt. Oh yeah, this is a Maker Faire shirt from a long time ago. You tell me. I can't see. It's like 2016 or something like that. Maker Faire cruise shirt. I think Maker Faire Miami is going on this weekend. So if you're in that area, go check it out. It's a really cool Maker Faire. I've been there one time before. Loved it. Let's see. Other thoughts or questions? Todd says, that's definitely not 280 BPM. Okay, yeah. I think, like I say, we're stretching the limits of CircuitPython there, so maybe I should constrain that into something a lot more realistic, because I just don't think it's going to be able to keep up after a certain point with all that overhead. But I can pretend, right? Todd brings up Bootloader. Great name for a podcast. Yeah, go check out the Bootloader podcast. That's my favorite podcast. Paul Cutler and Todd Kurt. Great podcast. Go check it out. All right. I think that's all the questions I see in the chats. So we'll wrap this up. Before I go, I'll remind you, if you want to go to the Adafruit shop and buy some cool stuff, if you want to build one of these, I'll tell you what you need. A Metro RP2350, the DVI breakout for it, the TLV 320 DAC 3100, and one of the little USB hub breakouts we have. Is that all? I think that's all you'll need. And of course, a HDMI display of some kind over DVI. That'll set you up. And a mouse. And speakers. So anyway, if you want all that stuff, go get some. Get 10% off with that coupon code today. All right. Thanks, everyone, so much for stopping by. We've got, I believe, a deep dive with Foamy Guy tomorrow. There should be some Desk of Lady Ada shenanigans over the weekend. We'll be back on Tuesday with another product pick of the week. Wednesday with 3D Hangouts, Show and Tell, Ask an Engineer, and Rinse and Repeat. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. I will see you next time. Bye-bye.